So in the last few videos, we've talked just about the idea of there being different ways to see if variables are related to one another. Is there a relationship between some variables that we're studying? And our very silly example of that was just investigating whether there was a relationship between eating spinach and a person's IQ. And based on both of the ways that we approached that and the fake data that we made up, we would be valid, we would be correct in concluding that, yeah, people who eat spinach, it looks like they have higher IQs. If we have confidence that the IQ test really is measuring intelligence, we could even simplify that and say people who eat spinach are smarter than people who don't. Now I want to make another claim, and that is that eating spinach makes you smarter. And I encourage you to pause the video and think about whether, if it doesn't immediately jump out at you what the answer is, think about whether this is a valid claim that we can make, and if so, why, and if not, why not. So the key term here is makes, the word makes, because what this is implying that one variable is causing. This is implying cause or causation. It's implying that spinach causes a change in intelligence. It causes you to be more intelligent. And this issue of, and I'm going to write this down, this issue of a causal relationship. This is a special type of relationship. This is going a step beyond just saying that two variables are related. This is saying not just that they're related, but we know how they're related. We know why. Saying they're related is saying they're changing in some consistent, predictable way. When one of them goes up, the other goes up, or when one of them goes up, the other goes down. There's some kind of a consistent way in which they're changing together. But saying that there's a causal relationship is going a step further and saying we know how they're changing together and why they're changing together. Because if a person eats more spinach, so spinach consumption goes up, we are claiming that intelligence goes up because spinach consumption causes you to be more intelligent. So now let's think about whether that is true, whether we can validly make that claim. So what we're saying here is we've got our two variables. Spinach and intelligence. And what we know is that there's a relationship here between the two variables. We know that they are co-varying, that they're changing together in some consistent, predictable way. What we are claiming now, let me grab a different color here. What we are claiming is that spinach causes intelligence. And this is something you'll commonly see, by the way, in scientific papers, that when we are just showing a relationship between variables, scientists will draw a line. If we believe that that one of them is causing the other, we will put an arrow instead of just a line. So we're saying that spinach, because people who eat more spinach are smarter, we take that to mean that spinach makes people smarter. And the question is that a valid claim? And what we have to think about is, let me actually write this down, are there alternative explanations? This is the big question. Are there alternative explanations other than our explanation is spinach causes intelligence? Are there alternative explanations that could account for the same results? Is there some other way in which we could imagine that these variables would be related, where, the relationship holds true. Yes, spinach and intelligence co-vary in this way. They change together in this way, but there's some other explanation for that. And sure, we could imagine that maybe more intelligent people have a better idea of what they should be eating, or maybe they tend to eat more fruits and vegetables because they read about it more in health magazines or whatever reason. So we might imagine that the causation actually goes in this direction, that being smarter, being more intelligent makes or causes you to eat more spinach. And that seems like a perfectly feasible, reasonable explanation. So when we are not able to rule out those alternative explanations, we're not justified in claiming that we know the nature of the relationship. We just know that they're related in some way, but we don't know why. And we can't make the claim validly, make the claim that the one variable is causing the other. Now, there's a way that you'll hear this principle phrased, and it comes from the idea that a lot of the time when we're looking at a relationship, we're looking at a correlational relationship. So this type of relationship is a correlation. This one over here is not a correlation. So I think this phrase is maybe not the best phrase, but you'll often hear it said like this, that correlation, and this is one of those key things to tuck away in your head, because you'll definitely, this is the kind of thing that research methods teachers love to test on, and it's really critical for understanding when you go to design your study, and also just when you read about things in the news, you will see this coming up all the time. But the principle is correlation does not imply causation. This is a really fancy way of saying just because we've seen that some variables are related, we can't jump from that finding to the conclusion that they are causally related, that the one thing is causing the other. So correlation does not imply causation. And like I was saying, I think this is maybe not the best way of phrasing this, because we have relationships that really aren't correlations. So we could just say, finding a relationship does not imply that you have found a causal relationship, that the one thing is causing the other. And then the question is, how do we demonstrate a causal relationship? And the way I will get into that in a future video, but just to give you a preview, the way that we're going to do that is by conducting an experiment. So you'll see this term experiment thrown around all the time. We use it in everyday language to mean a number of different things, or just sort of in a more general way. But in science and research methods, it specifically has to do with the type of study that you would conduct in order to prove, demonstrate that one variable causes another. And that's what we'll get into that next, in terms of what does that look like? What are you actually doing in an experiment?